Hello, Grant Swam at Gearhead School, and in this video we're going to take a look at how we make cold air. Well, we can't really make cold air. Cold is the absence of heat, and so we really got to move heat to make something cold. Cars' interiors move heat from inside the car to outside the car using the air conditioning system that's very similar to what's used in your house. And what you have to do is, like I said, to make the inside cooler, you got to take the heat to the outside. And also the process of cooling the car, we also pull a lot of moisture out. That's a big plus that we don't think about typically, is we're cooling off the air, and that process also pulls a lot of moisture out of the interior, dehumidifies, which makes it feel better. That's why you see a lot of cars in the summertime sitting there water dripping out. They're actually just a drain to carry the condensated water back outside the car. So for all practical purposes, air conditioning on most cars is running year-round to control the humidity, to keep the windows from fogging up, and to make it feel better in the car. They'll pull the moisture out, plus heat it back up and make it nice dry air. Feels good. So how to remove heat? Well, if you look at the timeline, we're going to try to walk through this. Now there's a baseline there going horizontal. That is 32 degrees. And so you notice we start off with ice is 0 degree Fahrenheit. So we actually start off with ice that's 32 degrees below freezing. And we're going to add about 32 BTUs. A BTU is a unit of heat. So we go 32 BTUs to take the block of 1 pound block of ice at 0 degree Fahrenheit, the 1 pound block of ice at 32 degree Fahrenheit. Now we have ice at 32, we have water at 32. And we'll see what makes the difference. Now, once that ice goes from 0 to 32, we added heat to make that happen. And since we saw the thermometer rise, we could see that. It's called sensible heat. It's measurable. We know it happened. We saw it warm up. Now at 32, that ice is going to stop getting warmer. And then as we continue to add heat, it's going to change from all ice at 32 to all water at 32. Now, since that thermometer didn't rise, if we had a thermometer embedded in this process, we wouldn't see any change in temperature. But we added 144 BTUs to that block of 1 pound block of ice to change it to 1 pound block of water. That's called latent heat. It's hidden. Because we didn't see the temperature rise, but it took that much energy to change from a solid to a liquid. Now, once all the water gets over to 32 degrees, we'll start to see the climb again. As we continue to add heat, the water's going to go from 32 degrees up to 212. Yes, we're going to have water at 212, and we're going to have, if we continue to add heat then, we notice that at 212, the line flattens out again. The latent heat we added to change from a solid to a liquid is called latent heat of fusion. And now we get the second state. We're going to change the water to steam. That's called the latent heat of vaporization. And the magic is that's where it happens. It takes a tremendous amount of energy to change from a liquid to a gas. So to change 1 pound of water to 1 pound of steam, it's 970 BTUs has to be consumed to make that happen. That's the magic of air conditioning. It takes a tremendous amount of heat to change the liquid to a gas. It's called latent heat of vaporization to change it over. Now, we can take the 1 pound of steam, it can capture that and cool it back down. It goes right back to a liquid. Now, obviously, we don't use water in the air conditioning system, but for all practical purposes, this is what we do. It's a refrigeration cycle. It's going to take a liquid that will change from a liquid to a gas at much lower temperature, which is refrigerant. Like people say Freon, which is a trade name of R12 from many years past, but it's a refrigerant which can change from a liquid to a gas at a lot more lower temperature. Over on the left-hand side, you'll see a real simple mock-up of the changes of state of the gas and liquid. Trust me, air conditioning is much more complicated than this. This is how it works at the core. You have all kind of controls on how to make sure it doesn't get too cold or too hot, and we don't freeze up the evaporator and turn block of ice inside the car, and how to deal with the engine revving up and down that drives the compressor. There's a lot of controls that are outside the scope of this video. So we're just going to look at how we do the change of state in a car and move the heat from inside the car to outside the car. So now let's take a look at the refrigeration cycle. We're going to take a look at how we change from a gas to a liquid, liquid to a gas. And like I say, we change from a liquid to a gas inside the car. We evaporate and pull in heat, take on the latent heat of vaporization. This latent heat means it changes state but doesn't change temperature. Pump it to the outside, condensate it back to a liquid, and bring it back around. So everything on the left-hand side of this, the left-hand side of the compressor, and number 2, that restriction, that's all going to be high pressure. Everything on the right is low pressure. So compressors pumping around through to 2, and actually at 2 we have a liquid. So we have a high pressure liquid. It goes through restriction into the low pressure side. And we take that pressure off of the liquid refrigerant and drop the pressure. It's going to start to change to a gas, because refrigerant will change from a liquid to a gas. Very low temperatures, not under pressure. So we depressurize it, and as it sprays refrigerant into the inside the evaporator, which is number 3, that's where it's going to change from a liquid to a gas. It's taking on latent heat of vaporization, pulls it right out of the cabin of the car. We're blowing our hot, moisture-laden air inside the car across the evaporator. It's pulling that heat right out of the air and changing the liquid refrigerant into a gas. Remember, that's called latent heat of vaporization. That the heat is causing it to change, because it doesn't really matter that much about the temperature of what comes in the car and outside the car. If you were to hold those 2 different pipes, you're not going to notice a big difference in temperature. You're like, well, how is this working? The magic is in the fact that you change from a liquid to a gas inside the car. You pull in huge amounts of heat from the latent heat of vaporization. Now when it leaves the evaporator inside, come back around into the compressor, it's still a low pressure gas. It came in as a low pressure liquid, changed to low pressure gas. You can't pump a liquid, so the compressor has got to be dealing with gas. Comes into the compressor as low pressure gas, and then goes to the high pressure side, the red side. And the reason it's high pressure is pumping against the restriction at 2. Remember? Now we put the gas, which is a lot of BTUs, and we pressurize that, get it good and hot, and then we blow air across it at 1. That's the condenser. And the condenser's out in front of the car. Looks like a little miniature radiator. So you're riding down the road, and we're taking ambient air and blowing across the condenser. And that's real hot because it pressurized it. Pull that heat off, and then that refrigerant, we pull the heat away, can go right back to a liquid again. So we use a material, refrigerant, that changes from liquid to a gas and gas to a liquid at a temperature that we can work with to cool a car. We're not dealing with ice, thawing ice and steam. It's just we use that as an example because that's something we're in our physical world. We see steam, we see ice, and we can kind of wrap our brain around the latent heat of fusion and latent heat of vaporization. That whole thing's repeated in an air conditioning system using a refrigerant that all happens at a lot lower temperature that we can use to move heat from inside the car. I hope this didn't confuse you. It is a topic that generally takes hours and hours to cover. We hadn't even got into controls, which is outside the scope of this whole course. This is the refrigeration cycle. This is how you move heat from inside the car to outside the car. It's the magic behind making something cold. All this material was pulled from a much larger lesson on the refrigeration cycle, which is one lesson out of 70 that I have in my Gearhead School course. If you'd like for me to help you learn more about cars, sign up. If you got any questions about the course, you reach me and I'll be glad to talk to you. Bye.